Okay, good morning, Year 4. Welcome to Thursday's maths lesson. We're heading towards the weekend, just 2 more lessons to go. We're going to start this morning with our usual 5-minute warm-up. You've got 5 questions to answer in as close to 5 minutes as you possibly can. 2 of them, these 2 here, are written method questions. These 3 here you might be able to have a go at using your number knowledge or mental strategies. So press pause while you're working and press play when you're ready to carry on. Okay, the first question we're going to look at this morning is this written method up here, 74 times 3. And 2 methods, as always. First one, I'm going to use abstract method of short multiplication. So we're going to start here. 4 3s are 12. We need to carry the 10 across into the next column. And then 7 3s are 21. Then we have to add in that 1, which makes 22. So our answer there would be 222. We could partition the 74 into 70 and 4, and we could then multiply both bits by 3. So 70 times 3 would be 210, and then 4 times 3 would be 12. So you've got then to recombine, so 210 plus 12 would be 222. You can see that both answers agree. Okay, second question, we'll have a look at this one here, 56 add 8. Okay, now what we've got to be trying to avoid here is counting on him using our fingers, for example, from 56. So we've got to look for some mental strategies that might be able to help us here. The first one I would say to do, or to try, maybe to partition 56 into 50 and 6. Then what I would do is add the 2 units together. So you've got 8 add 6 will give us 14, and then we would add the 50 onto it. So 50 plus 14 would be 64. And if we recombine that, you can see that's how we get our answer of 64. The second method we might be able to do is that if we wanted to, we could add, start on 56, add 10 onto it, which would give us 66, and then take away 2. And that would be the same as adding 8 on. Again, leaves us the answer 64. Okay, third question we're going to look at is this one here, 110 divided by 11. This is a times table division fact question, and it's asking how many 11s are there in 110? Well, 10 times 11 would be 110. Okay, so we were looking to know, it's our 11 times table, how many 11s make 110? So the answer to this one would be 10. Okay, next question, 8,432 take away 8,384. Now, the first thing I'm noticing are that these 2 numbers are quite close together. So I will give you a written method, and then I'll try and give you a mental strategy that you might be able to use as well. So here, what we would do is line up the numbers to make column subtraction, and we'd have 2 take away 4. We can't do that. So we have to borrow from the next column here. So we'd have 12, then we'd take 1 from there, so it'd be 12 take away 4 would be 8. We then would have to come to the next column and we'd have 2 take away 8. Well, we can't do that, so we would need to exchange from the next column, which leaves us with 12. 12 take away 8 would be 4. I've got 3 left over here, so it would be 3 take away 3 would be 0, and 8 take away 8 would be 0. And you can see that when you take this number from the top number, you're left with only 48. So those numbers are quite close together when you're dealing with numbers in the thousands. So how could we come up with a strategy that might help us be able to find this without having to do column subtraction? Well, you could count up from 8,384 to 8,432. So we could start with 8,384 and count on to the next 100, which would be 8,400. And in this case, that would be 16. So if we add 16 to this number, we get 8,400. Then we've got one more jump, which will take us to 8,432, which will give us 32. That jump will be 32. We then need to add these 2 jumps together. So 32 plus 16 would be 48. And you can see then you've got the same answer as over here. Now, this isn't a method that you might want to use, but it's worth thinking about. Because when you subtract, when you find the difference, you can actually find the gap between the two numbers. You can count on if you want to. Okay, and finally, we've got 3/5 of 50. Now, it's a little while since we've done one of these finding fractions of numbers. And you must remember that to find a fraction of a number, you first divide the whole number, which is 50, by the denominator, which in this case is 5. That will give you 1/5. Okay, so remember we're looking for 3/5, but the start point is to find 1/5. So we would divide 50 by 5, okay, which gives us 10. How many 5s in 50? 10. And then finally, we've got 1/5, which is 10, but what we need to do is find 3 of them. So we would times that by the numerator, which is 3. So 10 times 3 would be 30. And this will mean that 3/5 of 50 is 30. Okay, for the main part of our lesson today, our learning attention, we're going to be looking to describe the movement of a shape from one point to another. Okay, we're going to be describing the movement of a shape from one point to another. And when we're describing the movement of a shape from one point to another, the style words we're going to be using, the most important word we could be using this morning is translate, to translate. Okay, that is a key word, one word you really need to remember of this morning's lesson. Okay, and if we are translating a shape, it would be a translation from one point to another. We'll also be using the x-axis and the y-axis again. Now, if you remember, the x-axis was the horizontal line on a chart, and the y-axis was the vertical line. Those two we used when we were discussing coordinates and position and movement earlier on in the week. Okay, our in focus task this morning is that we're looking at the blue triangle here, and we've got to describe the movement of this triangle to each of these points. So how this blue triangle could move to where the red one is, how it could move to where the yellow one is, and how it could move to where the green one is. And if we were going to do that, we would be thinking about the word translate. We would be translating the shape, moving the shape from one point to another. So our job during the in focus, or to solve the in focus task this morning, will be to describe how we could do this. Okay, let's learn. Well, the first thing we can see here, if we were going to move the blue triangle up to where the red triangle is, what we would need to do, okay, is we would need to think to ourselves, right, if I'm going to describe this translation, this movement, what I would need to do is take one point of reference, okay, one point that we're going to move, all right? Now, in this case, for this triangle, I'm going to take the top corner here, the top vertex, and I'm going to see what I need to do to move that point there so that it sits directly on top of the same point on this red shape. So here, what I'm going to be doing is I'm going to move the shape, or this point, 1, 2, 3, 4. So the shape here will move up, okay, it will translate up by 4 units or 4 centimeters. And you could just check that to make sure that it's the same for all of them. 1, 2, 3, 4, and 1, 2, 3, 4. So you can see this shape is moving. If we were going to describe the translation or the movement, it would move up by 4 units or 4 squares or 4 centimeters. That's the translation. Now this time, the blue triangle is going to be moving to where the green triangle is. So again, I would take the point of reference, I'd pick one of these corners that I'm going to move, and I would check to see exactly where it moves so it's laying on top of the other one. So here, if I took this right angle here, it would be 1, 2, 3, 4. So the translation would be 4 units to the left. The 4 units to the left. As this young lady is saying here, it doesn't turn, the shape doesn't look any different, and it doesn't flip or be reflected. The shape will be exactly the same when it is moved to this point here. So the translation is 4 squares to the left. Now this one's a little trickier. Okay, this one's a little trickier because if we're going to take the translation to here, we can't just say, oh, we're going to diagonally move. Okay, what we would need to do is move the shape across first and then up or down. In this case, down. So you can see that if I took this as my, I'm going to take the top angle as my point of reference. I am going to move or translate the shape, first of all, so that it is in line with the yellow triangle. So here, it's going to be 1, 2, 3, 4 to the right, 4 units to the right, and then I've got to count down. So it will be 1, 2, 3, 4 units down. So my translation would be 4 right, 4 down. But we always, thing to remember here, we always go across first. What we don't do is go down and across. It's always across first. Remember when we were plotting coordinates, we always went across first. Well, it's the same with translation. So 1, 2, 3, 4 to the right, and then 1, 2, 3, 4 down. Okay, now it's your turn, and we're back as we were when we were looking at this map from a few days ago, when we were talking about position a few days ago. So we've got the 4 roads and we've got the 4 tourist attractions. So we've got the cathedral, the ancient ruins, the palace, and the museum. And your job this morning is to describe how you would go from one point to another. Okay, so you're translating the point from one place to another. So for example, I'll go through the first one with you. We are moving from the cathedral to the ancient ruins. So the cathedral is point C, the ancient ruins would be A. And in this case then, the translation, the movement would be 1, 2 units to the right. Now what I want you to do is to do the other 4 for me. Okay, the other 4, and to describe the movement from one point to the other. Okay, so press pause while you're working on this and press play when you're ready to come back. Okay, so if we move on here, we've got the palace to the ancient ruins. So we've got to go from P to A. In this case, we would just move it nice and simple, 1 unit up. The next one here, we've got the palace to the museum. So if we were going from the palace, which is P, to the museum, it would be 1 unit to the left. So the translation would be 1 unit to the left. The next one would be the cathedral to the palace. So we're going from point C to P. Now remember, we have to move across before we move up or down. So the translation would be 2 units to the right and 1 unit down. So 2 right, 1 down. And then finally, from the museum to the ancient ruins, we would have to go 1 unit to the right and 1 unit up. So the translation would be 1 right, 1 up. Okay, this next question here is asking you to translate this shape from here to here. Okay, and the young lady is saying, could you describe how this shape moves so that the red square ends up on top of the red square? Okay. So always have a look at this question, and then while you're working, press pause, and when you're ready to hear me talk about it, press play. So press pause now. Okay, so you had to show, this was the original shape, and it had to end up here. So you had to decide which of these translations, which of these statements are correct down here, okay, and which one is not quite right. So the first one, it says that it moves up by 3 units. Well, the red square, it will eventually move up by 3 units. What I think the best way to carry out this question will be to actually make the translation and then look at the statements. So here I'm going to start with the red, and I'm going to move 1, 2, 3. It's 4 to the right, 4 units to the right, and it's 1, 2, 3 up. So the translation here would be 1, 2, 3, 4 right, and 3 up. Now, if I look at the statements down here, it says the shape moves up by 3 units. Yes, that statement is correct. The second statement, it moves to the right by 4 units. Yes, that statement is correct. But the third statement, it says it moves to the left by 2 units. That is incorrect. As we've said, we move, the translation is right 4 units, up 3 units. So these two would be correct, but not necessarily in that order. Okay, it's now time for your independent learning. I'd like you to complete worksheet 4 on pages 161 to 163 of your workbook. That'll give you more practice on translation, on moving of shapes. And just remember, when you're doing it, take the point of reference. Decide which point you're going to move on the shape, and then move it into the same place on the other shape. Okay, so it's making sure that you are moving the same point each time. You're not changing the point halfway through. Okay, have a good go at this, and I'll speak to you tomorrow.